Now we're going to be covering the dermis, and we're going to be talking about the structures and the functions of the dermis. The second deeper part of the skin, which is the dermis, is going to be composed of this strong, dense, irregular connective tissue that's going to contain collagen and elastic fibers. It is going to be much thicker than the epidermis, as we can see here from this image. Notice how the epidermis is this darker area of the image, and the rest is all the dermis. And this thickness is going to vary from region to region in the body, reaching its great thickness on the palms of the hands and soles of the feet. The dermis, it has great tensile strength, which means that it's going to be resistant to pulling and stretching forces. It also has the ability to stretch and recoil easily, which means that it stretches and it goes back to its original position. As it is typical of all general connective tissues, the cells present in the dermis, they're going to be scattered, and they're going to include what we call fixed cells and wandering cells. Fixed cells means that they do not move, and wandering cells means that they do move around. The predominant fixed cells are the fibroblasts, and the wandering cells are going to include macrophages, mast cells, eosinophils, neutrophils, and even a type of cell that's called dermal interstitial dendritic cells, and they're all going to be part of the immune surveillance cells. Blood vessels and nerves, along with glands and hair follicles, which are two epithelial invaginations of the epidermis, are going to be embedded in the dermal layer. We will cover these in more details in the next learning outcomes. The dermis is essential to the survival of the epidermis, as we have seen that it is the one that supplies the nutrients from the blood vessels that will diffuse into the epidermis. And these adjacent layers will form many important structural and functional relations which are going to be important to support the tissue. Based on its tissue structure, the dermis can be divided by a distinct boundary into a thin, superficial papillary region, as you can see right over here, and a thick, deeper reticular region, which is the bottom half. The way I remember is that P comes before R, therefore the papillary region or layer is above the reticular region or layer. The papillary region makes up about 1/5 of the thickness of the total layer. It will contain thin collagen fibers and fine elastic fibers. As you can see on this image, when you compare the papillary layer and the reticular layer, you can notice how the fibers here in the papillary layer, they do appear thinner than in the reticular layer. In addition, its surface area is going to be greatly increased by these small finger-like structures, as you can see over here, that are going to be projected into the bottom surface of the epidermis, and these projections are called dermal papilla. These will greatly increase the surface contact between the papillary region and the epidermis, notice right over here, just like the microvilli that are present in the digestive system, which increases the surface area of the small intestine to be able to increase absorption. The dermal papilla can vary greatly in size and number throughout the different parts of the dermis. They are going to be taller and more numerous in sensitive regions of the skin that experience, for example, mechanical stress. In the skin covering most of the body, the dermal papilla are going to be relatively few in number. They're going to be small and irregularly scattered. By contrast, the thick skin that's located in the palms of the hands and soles of the feet, the papilla in this area are going to be relatively numerous and tall, and they're also going to be arranged in patterned rows. All dermal papilla contain capillary loops, which are blood capillaries. Some contain these encapsulated touch receptors that are called tactile corpuscles or Mason's corpuscle. As their name implies, tactile corpuscles are going to be sensitive nerve endings that detect touch, as tactile means touch. Still, other dermal papilla contain free nerve endings, which are dendrites that lack any apparent structural specialization, meaning that they can detect a variety of sensations, and these sensations can range from warmth, coolness, pain, tickling, and itching. Therefore, they're not very specific. The reticular region or area, which is this one right over here, which is attached to the subcutaneous layer, it's going to contain bundles of thick collagen fibers with also scattered fibroblasts in the middle of these collagen fibers. And you're going to also have various wandering cells such as macrophages, mast cells, neutrophils, in addition to some very coarse elastic fibers. Also, there's the presence of some adipose cells that can be present in the deepest part of the layer, which will sort of be a continuation of the hypodermis. As in the hypodermis, you do have a lot of adipose cells. The collagen fibers in the reticular region are going to be arranged in a net-like manner, as reticular means net, and in a more regular formation than those in the papillary region. As you can see from this image, the reticular fibers are somewhat organized. The more regular orientation of these large collagen fibers, they are going to align with the local tensile forces to help the skin resist stretching. Blood vessels, nerves, hair follicles, sebaceous oil glands, and sudoriferous sweat glands are going to occupy the spaces between the fibers. When we cover the accessory structures, you're going to be able to understand how they are arranged within the dermis. Here on this slide is just a little summary of the papillary region and the reticular region. The surfaces of the palms, the fingers, the soles, and the toes as well are going to be marked by a series of ridges and grooves, as we can see here on these images. They appear as either a straight line, as you can see here in the palms of your hands, or as a pattern of loops, as you see on the tips of your fingers. These structures are called epidermal ridges, and they are going to be produced during the 3rd month of the fetal development, as the epidermis is projecting downward into the dermis between the dermal papilla of the papillary region, as we saw on the previous slide. The epidermal ridges, they're going to serve multiple functions. They will increase the surface area of the epidermis, and thus it will function to increase the grip of the hands and foot by increasing the friction. They will also create this strong bond between the epidermis and the dermis in the regions of high mechanical stress. In addition, because of the increase of the surface area, it will also allow for the increase of the tactile corpuscles, which will then increase the tactile sensitivity, as the tactile corpuscles are there to allow you to feel sensation of touch. Due to the fact that the ducts of the sweat glands, they open on top of these epidermal ridges as sweat pores, this means that the sweat in the ridges will form what we call fingerprints or footprints. This epidermal ridge pattern is usually in part genetically determined, but even identical twins, they do have different patterns. Normally, the ridge patterns does not change during life, except for the fact that when you get older, it does enlarge a little bit. And this is why it allows us to use these fingerprints as a permanent basis to identify individuals. The study of the pattern of these epidermal ridges that is concerned with the identification and classification of fingerprints is referred to as dermatoglyphics, where glyphics means carved work, and dermato means skin. In addition to forming these epidermal ridges, this complex papillary surface of the dermis has this other functional property, which is the dermal papilla, which we already talked about in the previous slide. Now, this dermal papilla will fit together with the complementary epidermal ridge to form an extremely strong junction between the two layers. And this jigsaw puzzle-like connection, it's actually strengthening the skin against forces that are trying to attempt to separate the epidermis from the dermis. So, what keeps the epidermis and the dermis together is the presence of the dermal papilla together with these epidermal ridges. In certain regions of the body, the collagen fibers within the reticular region or reticular layer of the dermis, they do tend to orient themselves more in one direction than another because of the natural tension that's resulting from bones that are projecting in our body, in addition to the orientation of muscles and movements of joints. These are called tension lines in the skin that will indicate the predominant direction of the underlying collagen fibers. We can see on this image over here an interior and a posterior view of these tension lines in the body. And knowledge of the tension lines is especially important to plastic surgeons so that they know exactly where to do the incisions. For example, a surgical incision running parallel to the collagen fibers will heal with only a fine scar. A surgical incision that's made across the rows of fibers will disrupt the collagen, and this means that the wound might tend to open up or even heal with a thicker scar. So it's very important as a surgeon that you understand the tension lines and where they are located. If you ever wonder why women have more cellulite than men, this is because the dermis is typically thinner in women than in men. And the cellulite is formed because of the collection of fat cells in the hypodermis. And if you have a thinner dermis, then you're able to see these pockets of fat more clearly than you do in men because they do have a thicker dermis. It does not mean that they don't have cellulite, it just means that you can't really see it due to the thickness of the dermis. If the skin is overstretched, then the dermis may rupture and leave these lines that are visible through the epidermis. These lines of scar tissue, they're called stretch marks, and they can develop in the skin of individuals who have experienced rapid growth. For example, stretch marks commonly form on the abdomen and breasts of women during pregnancy or on the skin of athletes who have quickly increased muscle size by intense weight training, as seen on this image.